Although more than 17 years have elapsed since Tomcat first went to sea aboard the USS Enterprise, the interval since then has witnessed little change, and the Tomcats now being manufactured are essentially similar to those which rolled from the Calverton production line during the 1970s. The Tomcat has remained largely unchanged says much for the design of the aircraft and its associated AUG-9 weapon system. But the F-14A has suffered from its fair share of problems, most notably with regard to the TF-30 power plant. Improvement initiatives aimed specifically at the Pratt & Whitney power plant did succeed in alleviating some of the worst vices. Nevertheless, the engine was still prone to compressor stall and demanded extremely careful handling during air combat maneuvering. It was, of course, initially intended that the TF-30 would only ever be an interim power plant of the F-14A, production soon switching to an F-14B variant with a definitive engine. For a time in the early 1970s, it looked as though a version of the Pratt & Whitney F-100 turbofan, known as the F-401, would fit the bill. And indeed, an F-14B prototype did appear. Flying for the first time on the 12th of September 1973, the F-14B eventually accumulated the modest total of 33 hours between then and April 1974. In what was described as a reasonably successful test program. But this was accomplished against a background of financial difficulty, which at one time looked like it would seriously threaten the future of both Grumman and the Tomcat. Not surprisingly, most resources were directed towards continuing production of the F-14A, with the result that the F-14B passed into limbo despite showing some promise. Another derivative, the F-14C, which would have introduced new, more advanced electronics, also fell victim to economies. And as a result, the F-14A became the definitive production model. It was not until the latter half of the 1970s that serious consideration was again given to the question of re-engineering Tomcat. Flying from Calverton as the Super Tomcat for the first time on the 14th of July 1981, a re-engined Tomcat undertook a modest series of development flights, performing 30 sorties. In almost every aspect, this testing revealed significant performance gains, which culminated in a decision to go ahead with full-scale engine development as the F-110 in October of 1982. For instance, loiter time when engaged in the combat air patrol mission was up by 34%, while deck-launched intercept radius with Mach 1.3 flyout rose by no less than 62% to the order of 275 nautical miles. The greatly increased power output also permitted catapult launches to be made dry without afterburner, a factor which must have greatly impressed the Navy, since some of the earlier accidents had arisen from compressor stall when employing afterburner during launch. In fact, the F-110 engine displayed great resistance to compressor stall throughout the flight envelope, permitting unrestricted power management, something impossible to achieve with the TF-30. Impressive though these results were, it was to be another couple of years before the Navy elected to go with this new power plant. The U.S. Air Force moved first, ordering the F-110 into production for the F-15 Eagle and F-16 Fighting Falcon during February 1984. And the Navy soon followed, announcing selection of the F-110 to power a new Tomcat model to be known as the F-14D. Although earmarked for installation on the F-14D, the F-110 made its fleet debut in the F-14A+, which was delivered to operational Tomcat squadrons in the spring of 1988. Future Tomcat pilots undergoing undergraduate jet flight training will go aboard the first time in the new McDonnell Douglas T-45 Goshawk. The Goshawk is a modified version of the British aerospace-built Hawk, which has been modified for aircraft carrier operations with strengthened landing gear, an arresting hook, and catapult launch fittings.